Hey, welcome back to Fix Everything on this rainy, cold end of October. Today, went to make toast. Things light up, but no coils are turning red. This is a quartz convection toaster oven from Krups. It's gotta be 15 to 18 years old. So the controls work: bake, broil, convection bake, defrost, toast. But when you start a cycle, the clock works. It's counting down. No action in here. So there's no heat, no coils. I'm betting that 4 coils didn't just explode and die on me. Pretty sure it's a fuse inside, maybe a loose wire. Don't know, but we're going to open her up and take a look. Looks like 1, 2, 3, 4, 5, 6, 7, 8, like 9 or 10 screws. I'm sure there's a bunch underneath as well. So 9 on the back, looks like there's one here. This is probably a clip. And then there's another one down here as well. So you got to remove the feet. 1 bar, 2 bars. And after further review, there's 1, 2, 3, 4. So there's 4 more in here because this faceplate has to come backwards so that this can come off. And of course, hiding under a rubber foot peg, another screw in there. So you have to remove the back 2 rubber pieces. And then after the screw is removed, that foot comes out and it reveals the bottom of the cover, which should just pop right out once I pull the face towards this way. Yeah, it's going to do that. So let's do this one now. And there we go. So just put those 2 aside. Keep your screws and all your parts so that you can access them later. We're just going to pull this face forward. Now there's a spring in here because the door is spring loaded. So that might be a challenge. I kind of wrestle with it, but this all comes apart. Just don't drop anything. It's kind of stuck on the other side here, so hard to shoot and pull this at the same time. So this is the area we're looking for. There's fuses, wires, circuit board, everything's in here. So I'm sure the culprit is somewhere down in here. So let's have a look. So now with the cover removed, just take a look at the screws. Make sure everything is tight, no loose wires. Looks like everything is, that's supposed to flex like that, I'm pretty sure. So yeah, all the wires on this side are tight. That's the left side of the filament. And everything looks great in here. Nothing's broken. And then over here, we'll take a look at the same things. Wires are all in place. All this does is, that's a piece of quartz. It's a quartz tube right here. And inside, all it is spiral wire like you'd see in an old-fashioned toaster. So the wire glows, which heats up the quartz and gives you a nice even warmth that comes off of it. So I'm pretty sure that that looks okay. So we're going to plug this in and hope I don't get electrocuted. So before I plug this in, there's a fuse here. It looks like it's the only one. There's a capacitor, some resistors there, but I'm just going to do a continuity check on that fuse. Obviously electricity should be passing from one end to the other when this is turned on. So if I just do a continuity check, I can see if that fuse is blown. If it is, I can order the fuse and unsolder it from the board and put it in. Let's take a peek. Have my multimeter set to continuity right there. And if you cross the leads, you get an indicator that the circuit is closed or good. So we're getting a positive reading there. So that fuse is good. Next thing we take a look at is the wiring. Is there anything loose on the circuit board? There's a harness here. This looks like it's pretty tight. Make sure this is not plugged in, obviously. I'm just going to push down on some of these connectors here. Make sure they're tight. Everything seems rock solid in here. All right, so let me plug this in, and I'm going to use a screwdriver and just kind of push some things around, see if I can't get it to go. Maybe there'll be a telltale sign of what's up here. If not, it's probably circuit board related. Something's blown there as well. Power's up. I hear something buzzing in there. Not sure what that is, but let's hit start. Oh, just saw something spark. What the heck was that now? Let's try it again. It was over here somewhere. Let's get my screwdriver out. See if I can recreate that spark that I just saw. Whoa, whoa, right there. Culprit. Bad contact on that wire. Look at it glowing there. Let's unplug that before something happens. But right there, so it fired up and they started to glow momentarily. I can feel the heat inside the oven here. So right there, contact, not good. It's probably crunchy. Oh, in fact, look at that. It's not only crunchy, it's coming off. Yeah, the heat over time will make wires brittle, wire coverings brittle. You can see that somebody was in here. Maybe, hard to tell, but that other wire looks like it has been repaired. So let's try a repair on this. If not, we're going to chuck it and get something new. It's 16 years old after all, but gosh, it's a Krups and it's lasted this long and it's worked so well. So let's see if there's something we can do about that. Let's take this zip tie off so we can get some play in the wire here. So I'm going to try to clean that up and either put an end on it, but if there's no end on the other end to push an end into, maybe I can solder it like that one. Maybe it'll work for a while. Oh, that's really crunchy. Protective sleeve. There's the end of the tube. Those leads are hard soldered to the end of this tube. So I'm going to try to hard solder that. Shouldn't be too bad, to the end of that connector. Get a little sandpaper in there too. Emery cloth, whatever you got would work. I'm sure they make a connector of some kind for the end of this wire that will work well, but I'm also going to save the heat sleeve. I know it's not in the best shape, but it's better than nothing until I can order some and put the new ones on there. No one even put one on this one, but looks like it's working okay. Got that end cleaned up real nice, shiny, ready for flux and a soldering gun. So there's a hole on the end of this connector, so I just stuck the wire inside there rather than try to solder it to the side of the connector, which is kind of a pain to hold it at the same time. So this should suffice. Also remember to put your heat sleeve on before you solder the wire so you can slide it right over the top of the repair when you're done. I have two types of soldering irons. One is my little soldering station. I decided not to use that on this because a lot of heat is going to be needed because that's a pretty good shank of metal there. So I broke out the Weller 9000. I've had this a while, but this heats up very quickly. Great for a little bit more of a heavier, dutier solder that you might need. And I just cleaned the tip because a couple of videos ago somebody got on me, you know what, you need to clean your tip. You'll get a better result. And he was right. And that's all slathered up with flux on both the wire and the shank there, and it's ready for solder. So for this, you're going to need to leave your gun on there for a little bit to get a good heated surface on both ends. Wow, nice. Solder flowed inside the tube and grabbed both the wire and that shank connector quite well. Let that cool for a minute. So it looks like it adhered pretty good. So I'm tugging at this wire and it's on there, not going anywhere. This one I'll check again, but that solder seems to be holding as well. So let's put our sleeve back on. Just something to keep it protected. They probably sell these somewhere. They're, I don't know if they're asbestos, probably not asbestos, but they're heat shields of some kind. So let's give it a test run before we put it all back together. That's better. I hear a circuit buzz. The warm orange glow. That's what we love to see. And if I take a look at this, no more sparking. That's pretty scary. And of course, the wire looks great. Not moving, no sparks. Again, these things generate a lot of heat, so things get brittle and get crunchy. And once in a while, you just need to do a little maintenance. Hate to throw stuff away, you know. I always say if they put it together, it always comes apart and you can do it yourself. Just a quick troubleshooting. This could have been a fuse. That'd have been easy. This was even easier because I had all the materials needed to fix it. So I'm going to put this back together. And I want to thank everybody so much for the support. I'm up to 662 subscribers. I know in a giant pond that is absolutely nothing, but I want to say thank you to everybody for the great questions, the great support that you have given me over the last year. God bless all of you. If you need anything, just put it in the comments. Happy to answer if I can. And if you have any ideas for a post, I would be more than happy to accommodate if possible. Thanks so much for tuning in to Fix Everything, and have a great day.